force of the following situations. How do you find out the resultant force and what is called result? When several forces are acting on an object, concerning two factors, one is the value, the magnitude and the direction. So concerning both this magnitude and direction, we find out the simple or else the single force that can be applied on behalf of all the contributing forces. Okay. So what is the simple theory here? If you consider one direction, whatever the forces are given applied in that same direction, you have to take them as plus. You have to add them. Okay. To the considered direction, whatever the forces are there, you have to take them as plus. Opposite direction, if there is a force given, you have to take it as minus. Okay. Concerning the direction, same direction plus, opposite direction minus. So this is a simple theory you have to remember. So here in these questions, you can see, first one it gives you 20 plus 10. I have to take actually. But how do we write that? I'll take the resultant R. I'll mark the direction. Okay. Let me consider this as my direction here. And 20 Newton, you can see it is the same. So I can take it as plus 20. And 10 Newton is also the same direction. So 20 Newton plus 10, it is 30 Newton to the same direction. Okay. It's not must to be written with these arrowhead, but better if we write. So our answers, they won't go wrong. Straight away we can get the answers. Yeah, even if you are writing R is equal to 20 plus 10, 30 Newton you got, let's say. So 30 Newton to the right you can mention. And that is that the word is what we are marking like this. Resultant to the right. So look at the second one, resultant. Here also let me consider this as my direction. So it's my easiness. I'm taking all ways to the right. It's not must. It's not must. We can take according to the requirement. Let me take as to the right. Then 5 Newtons put there, you can see it is in the opposite direction, right? Then is it plus or minus? It should be minus. So minus 5 Newton. And the 10 Newton is in the same direction, right? Then it should be plus. Minus 5 and plus 10, how much is it? Plus 5. And this plus 5 is what we are showing in this arrow. So the resultant is 5 Newton. Resultant is 5 Newton. So usually plus we don't mark, right? Minus means we have the minus sign we have to mark. Plus we don't usually mark, right? As a single value when it comes, you do. So it is 5 Newton means plus 5. Third question. Let me take the same direction resultant. 5 Newton, both of them are in the same direction. I have taken it as plus. So resultant to the same direction, 10 Newton. Resultant to the same direction, 10 Newton. And here you can see the resultant I'm going to take vertical. Because the forces are given vertical. So if the forces are given vertical, you can't take them as horizontal. You have to take them vertical. So vertical forces are given, and you can observe the 50 Newton is upward, 40 Newton is downward. And let me take my resultant upward since 50 is more here. So I consider 15 as plus and 14 as minus since it is in the opposite. 15 minus 14, 1 Newton forces they are upward. So the resultant is 1. So let's say someone asks, is it must to be taken upward? No, you can take it down. Then what if it is taken down? Let's take it. I'll take the resultant down, let's say. My considered direction is down. Okay. Then 15 Newton must be minus 15, right? Am I correct? My considered direction is downward. 15 Newton is acting upward, so it should be the opposite direction, minus 15. And then 40 Newton should be plus as it is in the same direction. How much is it now? Resultant downward is minus 1 Newton, correct? Why? Minus 15 plus 14 means minus 15. So minus, in fact, it refers to, opposite direction is acting on. So downward, I'm considering it as minus means upward it should be plus. Downwards my answer is minus 1 means minus refers to opposite direction. That means I'm changing this minus into plus 1 Newton. So I have to turn up the direction. Okay, so you can see the same answer you are getting. Only thing is one more step added. Right? So this is how we find out the resultant forces. Got it? Let's find out the resultant for some other questions as well. Okay. again to find out the resultant in these cases. So early in the previous question, what we did was we found the resultant of collinear forces, same line of action. Those forces were acting on the same line of action. And now here you can see they are not on the same line of action, different line of actions. And also those lines are parallel. You can see they are parallel here, right? So parallel forces are what we take. Parallel forces are what we take. Now how do we find it out? Same method. Resultant to the same direction I consider it. 10 Newton, 10 Newton, both of them are in the same direction. So we take it as plus 10 plus 10. So the resultant should be 20 Newtons. 20 Newtons. Very easy. And here, let me take the same direction. 10, 5, all three in the same direction. So it should be 10 plus 5 plus 5. Totally 20 Newton, the resultant. Resultant is 20 Newton. Very simple. The theory is same direction plus opposite direction minus. That concept is what we have to apply. And better if you can go step by step, one after the other. Then you won't mistake that. Okay. And how about this? I'll take the same direction. Let's see. I'm starting up with this left to right. So left, you can see the 5 Newton here. It's in the opposite direction, right? So I'll take it as minus 5. Okay. And then one by one we'll take it's easy. 4 Newton should be the same, so it is plus 4 Newton. This 4 Newton is also in the same direction, plus 4 Newton. Plus 4 Newton. If you are taking it as a group, then only you need the bracket. One by one, when you are taking, you don't want to apply the bracket, you have to consult plus minus straight away and apply it. So now, minus 5 plus 4 plus 4 plus 8, 8 minus 5 is plus 3 Newton. So the resultant is in the same direction, 3 Newton. 3 Newton. And here, same direction I consider. And these 3 Newtons and this 3 Newton, both of them you can see in the opposite direction. So it should be minus 3 Newton, minus 3 Newton. And then the 10 Newton is in the same direction, plus 10. Minus 3, minus 6 Newton. Minus 6 Newton plus 10 Newton is plus 4 Newton. That means to the same direction, they have the resultant. So you can see how simple the questions are. Only thing I kept on repeating, you have to consider the direction. Same direction plus means opposite direction plus means minus. That is the concept you have to apply. Collinear forces and parallel forces both. Okay. Both the same way you have to. Next question. If an object is pulled by two forces, 10 Newton and 15 Newton along the same direction, what is the resultant of the two forces? So simply we'll draw a small diagram. It may be a circle or a box you are taking just to show it is an object. Now you see 10 Newton, 15 Newton along the same direction, but it doesn't mention if it is parallel or collinear. If it is on the same line of action or two lines of action, it doesn't mention. So you can take one of them. You can take one of them. Okay. So let me take, I'll consider it as parallel forces. So I'm marking like this. One I consider 10 Newton, the other one should be 15. And one more thing, here in these diagrams, that is not very much concerned, but exactly the graphical representation when you take for the forces, the length of the straight line that we take here should be to the scale. That means if you take this for 10 Newton, okay, bit more we have to take 15 Newton, almost about 1.5 times. That is because of this is the length for 10 Newton means 15 is 1.5 times more than that. They are right, 1.5 times more. So 1.5 times length you have to take to represent because it's a representation, a standard representation. So those theories we don't consider actually here that much unless if it is asking the question to the scale to do. Okay, and the drawing is also not must be. But to learn a small theory, I'm giving the diagram here. Okay. So 10 Newton, 15 Newton, I'm drawing this diagram. Right. So another person draws the diagram in this way. Look at this. He is drawing the diagram 10 Newton and 15 Newton here. Okay. But look at this. Both the forces in the diagram are given in the same direction, right? Can you see this is also to my right? It is also to the right. And both the cases, resultant will be also same. How much is the resultant here? resultant to this direction, you take it as 10 Newton plus 15 Newton, 25 Newton. So the resultant will be 25 Newton. Here also the same thing. Here also the same thing. But I say the first diagram I drew here is correct. The second diagram is wrong. What is the reason? Think. According to the question given here. According to the question given here. Second diagram is wrong. Why? You think, if you observe, you can see exactly the word pull. Okay, pull. It's being pulled. It's being pulled by. So the first diagram shows you a pull. The second diagram, it's not a pull, it's a push. Okay. So now the diagrams here, it is not to be drawn, but when you are drawing, you have to consider. Clear? Pull means pull, push means push. You can't exchange. Clear about that? All right. So anyhow, the answer is going to be the same 25 newtons. Better, we draw the diagram as well. Look at the next question now. Find the magnitude of x. X is an unknown value. It is a force. Find the magnitude of x. Okay. If the resultant is 35 Newton to the east. The resultant is 35 Newton to the east. Now, east and west, you must know this. Okay. So, this is the what direction? East. Obviously. This is the east, right? This should be the west, right? According to the board's plane here. Right? So, you can see x is acting to the east. 20 Newton is also acting to the east. Okay. And x 20, both of them are in the same direction. Question says that resultant is 35 Newton along the east. That means after applying, resultant means after applying x and 20 here, resultant, the total force is 35 Newton. 35 Newton. Question asked you to find out x. So how do we apply? Resultant to the same direction is equal to x 20, both of them are in the same direction, right? So how do we take that? X is plus, 20 is also plus, right? Okay. So how much is R now? 35 Newton. X we don't know, and